Hello and welcome everyone to the video. In this video, we will be looking at the concept of averages, and we will also be dealing with a concept called as allegations. Now, as far as the concept of allegation is concerned, we will try to ensure that we don't do it in a conventional approach wherein we have a peculiar diagram and you have certain numbers written in a certain format, you subtract a few numbers, take a few ratios. Rather than mugging up all of this as a diagram, I would want you to ensure that you remember the concept behind allegations, and then that will give you a freedom to apply it wherever you want. You don't have to look at a specific kind of questions to apply that. You can look at any kind of an averages question and can go ahead and apply all of that, and that will give you a real freedom on the paper to choose what you really wish to do and how you really wish to do the questions. So when you mug up certain things in a certain fashion, it restricts your application of that particular understanding or knowledge on only to a certain set of questions, wherein if you know the logics, you can then apply a particular logic at n number of questions and different varieties of questions. You can generate your own formulas during the paper. All of that is possible only with the help of concept. So we will look at the concept of allegation in quite a detail, and this will be the first part of a larger topic called as mixtures and solution. There will be another video in which I will be talking about removal and replacement, which is again one of those topics which people generally don't like and tend to find it slightly more difficult as compared to the other topics. So let's quickly deep dive into this particular topic and understand the first thing, which is nothing but averages. So what do we mean by, just a second, sorry, right? So let's look at the word averages. Now, when I get into my classroom and I ask students as to what do you mean by average, they always give me one particular answer, which is average is equals to sum of all observations divided by the total number of observations. Now, the problem with this is a method of computing average. This is not what we mean by average. Why did somebody in this world added all the observations and divided it by the total number of observations? That person could have multiplied all the observations and divided it by the total number of observations, call it something and make questions, right? So of course, making question was not the intent behind all of this. The intent behind all of this was this tells you something really important about the set of data which is given to you, right? So let's take one example and try and understand with the help of it as to what do we mean by average. Let's say suppose there's a class of 40 students and the average marks obtained by the class is 60. Now, if I put this data back into that equation of average is equals to sum of all observations divided by total number of observations, what we'll get? We'll say average is 60, which is equals to A1 plus A2 plus A3 up to A40 divided by 40, where A1, A2 are the scores of these 40 students, right? This is what it says according to the equation. Now, let me rearrange this equation a little bit more and understand what it gives me. So if I rearrange this and I write it as 60 into 40 is equals to A1 plus A2 plus A3 up to A40. Now, this gives me a better understanding of my word average. Pay attention to this. A1 up to A40 is what? This is the actual sum of these scores, right? Now, if you look at your left hand side, this actual sum is equals to 60 multiplied by 40. So they are saying each of these 40 students, if I give a score of 60 marks, what will be their total? Each of them getting a 60 marks 40 times. So 60 into 40, that should be the total. And this total is equals to the actual sum. This implies what? That average is nothing but an equal distribution of all the things which are available with us. We are trying to just do that. What is that equal value that I should give to each of the identity to come down to a situation wherein I'm not changing the sum total of the entire set of data which is given to me. That's all what we mean by average. It's a value which if is given to any of the or rather all of the identities in the system, then we don't change the sum total, right? So let me put that into words. This means that if each of these 40 students is given a score of 60 marks, then the sum total of the class will remain the same as that of the original distribution. This is all what we mean by average. Now, let us take one example and try and understand as to what we've just learned. How do we look at it in a practical format? I've given you one example. Let's take one more example. Suppose there is a set of numbers given to us. Let's say it is 53, 55, 57, 61 and 65. These are the 5 numbers given to us. And let's say, suppose I want you to calculate the average of these numbers. The obvious answer that you want to give me is, sir, let's add all of these numbers and then divide that value by 5, right? Now, rather than doing that, let's try and apply what we've just learned and see how do I equally distribute without using that formula, with just the concept of equal distribution. How can I get down to my answer? Of course, I'm not trying to teach you how to calculate average. What I'm trying to teach you is what that concept is all about of averages. Once you experimented with 4-5 numbers, it becomes easy for you to understand things going forward on other set of questions as well, right? So let me presume a number as the average. I don't know what is the average of these numbers. I'm just presuming a random number as an average, right? So let me take a number 50 as my average. So I presume that 50 is my average. Now, what we learned as averages, it is an equal distribution that we are looking at. So I will try to give 50 to each one of them and try to understand as to what extra value do I have. So if I give 50 to this person, I will have to pull out 3 from this person. So I will have a 3 extra available with me. Same way over here, 55, I will pull out 5 from this person. I'll pull out 7 from this person. I will pull out 11 from this person, and I will pull out 15 from this person. Now, if you look at this sum total, what do we get? 7 plus 3, 10, 15, 30 and 40, 41. So 41 is something that we are getting as an extra value available with us. So what can I do? I have given 50 to each one of them. And if I redistribute this 41 equally among 5 students, what will I get? 50 plus 41 by 5. This is an equal distribution. And of course, this is the average of the numbers, right? So this is something that we need to understand, that it is about taking everything and dividing it equally among all of them, which are or the number of identities which are available to us. Now, you might wonder that, sir, do I have to take a number which is always lower than all the numbers over here, or can I take any other random number for that matter? You can actually take any other number. Let me take one more example with the same data and try to tell you that how would you get down to the average. So let me say, let's say, suppose instead of taking 50 as the average, let me take 60 as the average. Now, if I take 60 as my average, then to this person, I will have to give 7 to bring him up to 60, right? So I will be running short of 7. Over here, what will happen? I will run short of 5. Over here, I'll be running short of 3. Over here, I'll have 1 extra. And over here, I will have 5 extra available with me. So if I now look at this total, this will get cancelled out. 7 and 3 is 10. So minus 10 plus 1 is minus 9. That means if I give 60 to each one of them, I will be running short of 9. Of course, I cannot pull in something from outside of this category or outside of this data that is available to us. So now what will I do? After giving 60 to each one of them, I will pull out something from each one of them such that the sum of the things pulled out should be what? Should be equal to 9, so that I am at 0, right? So what will I do? From each one of them, I will have to remove a quantity which is equals to 9 by 5, so that I ensure that from each one of them, I'm removing an equal quantity. So 60 minus 9 by 5 should then give me what? Should then give me the average. And of course, both the values have to be equal. There's no doubt about it, right? So this is a basic meaning of average. It is about distributing equally. I am repeating this again and again because this is something which is very crucial with respect to your understanding. And in order to really help you do the questions much better and understand allegations as a concept. Let's move on and let's look at the next part of it, which is allegations. I'm naming it slightly differently, and we will look at the concept of the entire thing. The concept, the heart of the concept is surplus being equals to deficit. But before I say surplus is equals to deficit, let me define what do we mean by surplus. So if there is anything which is more than the average, creates a surplus. So let's say, suppose I have a system of values. I have a set of values available with me. This set of values will have an average value. Some of these values will be more than the average. Some of these values will be lesser than the average, right? So this is how it is going to work. Now, those values which are more than the average creates a surplus in the system. The values which are lesser than the average creates a deficit in the system. So anything which is more than the average creates a surplus. Anything which is less than the average creates a deficit. This is the terminology that we will use. Now let's take one example. And in this example, I'm going to give you some numbers. Look at the averages of these numbers. Look at the deficit that these numbers create and the surplus that these numbers create, and then try to come down to a certain understanding about surplus and deficit. For the sake of convenience, I've taken a set of consecutive numbers because average is easier to calculate. So my average of these numbers will be nothing but 8. right? Now, if you look at the number 5, it is less than my average. So this will create what? It will create a deficit of 3 units. Same way, if you look at a number 6, it is running short of 2 by 8. So it will create a deficit of 2 units. Same way, 7 will create a deficit of 1 unit. If you look at 8, it will not create a surplus. It will not create a deficit. So that's a 0 for surplus or deficit. If you look at 9, it is more than my average. And of course, it will be creating a surplus of 1 unit. 10 will create a surplus of 2 units. 11 will create a surplus of 3 units. Let's take the total of deficit and surplus. So what is the total of deficit? It's going to be 6. What is the total of surplus? It's going to be 6 again. So can I then very certainly say that my surplus will always be equals to deficit in any set of values which is given to me? Now, be it any question, of course, your surplus will always be equals to deficit. And that's the beauty of the concept, that if you understand concept, you can apply it wherever you are looking at things related to averages. So my surplus will always be equals to deficit. Let me put this in the form of an equation, because that is what ultimately we will be using during the questions. So what have we done? We have said 8 minus 5, 8 minus 6, 8 minus 7. This is the deficit part of the equation, should be equals to the surplus part of the equation, which is 9 minus 8, 10 minus 8, and 11 minus 8, right? Now, let me rearrange this equation a little bit. Let me take everything to the left hand side, and this is what I'll get. 8 minus 5, 8 minus 6, 8 minus 7, 8 minus 8. And then if it goes on the other side, it will become 8 minus 9, 8 minus 10, 8 minus 11. And that value is equals to 0. Now, this equation has got its own relevance. Now, please understand, when I can calculate surplus easily in a question, when I can calculate deficit easily in a question, in any given question, then I can equate my surplus and deficit with the help of this concept. But in some of these questions, we might not know which one will create a surplus and which one will create a deficit, right? So in that case, what I want you to do is, I want you to take a convention and put that value equal to 0, because that is also correct. When surplus is equals to deficit, that means surplus minus deficit will always be equals to 0, isn't it? So what you can do is, you can calculate these values, 8 minus 5, 8 minus 6. So I want you to put average over here, take a difference with every value and put that value equal to 0. Some of these brackets will naturally be negative, will give you negative values. Some of these brackets will naturally give you positive values, and the entire sum would then become equals to 0. So let me put it in the equation format. X being an average, x minus 5, 6, 7, 8, 9, 10, and 11. Take the sum of all of these brackets and put that value equal to 0. Of course, it has to happen. There's no other way out, right? This is the basic concept of allegations. Now, I'm not going to make that diagram. I'm not going to put those arrow marks. I'm not going to say that put the larger value on the left, smaller value on the right, and then take a few differences. No, I'm not going to do that. So we will only hold on to surplus and deficit and do exactly same what we do in so-called allegations method. Okay. So before we move any further, there are a couple of things that I want to bring to your notice. First, reading and understanding the question is of a great importance. If you do not understand the question, forget about solving the question. So for example, I say that milk is added to a milk and water solution. What do I mean by this? Am I mixing milk and water? No, I'm not mixing milk and water. I'm mixing milk with an adulterated solution which already contains milk and water. So there, what am I doing? I'm taking a solution and I'm adding milk to this. If you read this as I am mixing milk and water, then I'll go wrong on this question completely. So got to read the questions very, very carefully. Now, at some point in time, they'll say that 2 mixtures of milk and water have been mixed. So you will have to understand that there's a milk and water mixture A, there is a milk and water mixture B. These two have been mixed. There will be certain ratios given, and then we will go about solving that particular question. So reading the question is of a prime importance. This is something that I wanted to convey as my first point over here. The second thing that I want you to understand is the difference between ratio and strength or concentration. These two things represent a similar thing, but in a different format. For example, if I say that the ratio of milk and water is 3:4, so can I then say that the strength is 3/4? No, I cannot say that the strength is 3/4. Strength will be 3/7. And when you convert it into percentage, we more often call this as concentration. We more often call this as a concentration. So over here, what will I do? I will refer to my strength in this fraction. So percentage converted to a fraction, is what we are saying over here, that concentration when converted to a fraction becomes its strength. So what is the strength? And when I say what is the strength, you really need to understand that I need to specify what strength am I looking at. So there might be two types of liquids that have been mixed. So I will have to tell you that I'm looking at the strength of which liquid in that solution, right? For example, over here, when I say milk and water ratio is 3:4, I'm 3/7 is the strength of milk. When I will have to write the strength of water, I will have to write it as 4/7. Be very careful with this in terms of what are we dealing with, because if we get confused there, then we will end up making mistakes. Okay. So now let's move on and let us try and apply the concept of surplus and deficit on a few more questions. First couple of questions, I've kept it easy, and I'm not going to give you much time to solve those questions. I'm going to directly go ahead and do these questions so that I can express myself as to how do you take that concept and apply it. Post that, I will give you time on about 7-8 more questions to do. Okay, so let's look at the first question. A merchant buys 2 varieties of rice, one at 30 rupees per kg, another at 90 rupees per kg. In what ratio should he mix the two so that he gets a mixture of 75 rupees per kg? Now, please understand this. I'm not giving you time to solve this. And of course, the question is pretty easy. What I want you to understand is how do I apply surplus and deficit on this particular question. So now what I want you to understand is there are 2 different varieties of rice that we are mixing. So there's a variety A, there's a variety B. One is at 30 rupees per kg. So if I give you an entire lot of the variety A and you pick up any 1 kg randomly from this, you will realize that that costs rupees 30. Right? So can I then say that the average price of this variety A is 30 rupees per kg? So you're dealing with a variety which has got an average at 30 rupees per kg. And there's another variety which has got an average of 90 rupees per kg. When you're mixing these two, you're getting a mixture which has got an average of 75 rupees per kg, which has got an average of 75 rupees per kg. Now understand this thing. This is the average of the entire mixture, correct? This value is more than my average of the mixture. This value present over here is less than my average of this mixture. So the variety A must create a deficit for me and variety B must create a surplus. And what should happen? My surplus should always remain equal to deficit because my average is given over here and I'm trying to calculate average. So with respect to average, my surplus and deficit must always be equal. That is the concept that we have learned. Now, you may end up saying that, sir, then 90 minus 75 will be the surplus and 75 minus 30 will be the deficit. But both are not equal. Of course, they will not be equal for a particular kg, but as a complete mixture, it will be equal. So what I'm trying to convey over here, 90 minus 70 is a surplus on 1 kg of the variety B. How many such kgs have I taken? Let me say that I've taken B kgs of this. So what will I say? 90 minus 75 into B. That will be my total surplus. What will be my total deficit? 75 minus 30 is a deficit on 1 kg. How many such kgs I have taken? Let me say that I've taken A kgs of this variety. A kgs of this variety. Okay. So what will I say? I will multiply this by A. This will be the total deficit. And both the values now, of course, must be equal. So 90 minus 75 will be what? 15B. And 75 minus 30 will be what? 45 into A. So what should be the ratio of A by B? The ratio of A by B is 15 by 45, which is of course 1 by 3. So I'm going to take what? I'm going to take 1 part of A and I'm going to take 3 parts of B to be able to get down to a mixture which is 75 rupees per kg as the cost. This is how you organize your data. What are the 2 things getting mixed with each other? What are their averages? What is the final average of the mixture produced? What are the individual quantities? If I can classify my data in this format, then I'm going to get down to the answers very, very quickly because this is not going to make any problems. Okay. Also keep one thing on your mind, that these values at the moment are visible to you. These 3 averages, right? So you know that this is more than the average, this will create a surplus. This is less than the average, this will create a deficit, right? Now let me say that you have a case wherein you have a variety A, you have a variety B. You want to find out the average of these 2 mixtures. You have a value A over here and you have a value B over here. Now, if these are the only 2 varieties that are getting mixed, and if B is more than X, then naturally my value of A has to be less than X. That means my average of the mixture has to lie somewhere in between these 2 values, isn't it? right? So this value will create a surplus and this value will create a deficit. So while making an equation, I am going to say that if B is more than X, then I'm going to do B minus X multiplied by the quantity of the variety B must be equals to X minus of A. Now, please understand this thing. When you are using variable, please do not put A minus X over here. That will then go wrong. Be very, very careful with this. Of course, we have to multiply it with the quantity of the variety A. Right? So please ensure that you are writing the right values at these two places. This is where students tend to make mistake when they are not able to see the numbers. Over here, we were able to see the numbers. So I know which value is more, which value is less. I can very easily decide this thing. But in some of these questions, you will of course have to use your brain to understand what need to be subtracted from what, right? Let's go ahead and let's look at the second question. Again, this is a question that I'm going to do it on the screen, but post this, I will allow you your time to do the questions from question number 3 and onwards. A merchant buys 2 varieties of rice. One is at 40 rupees per kg. Let's say suppose there's a variety of rice A and there's a variety of rice B. One is at 40 rupees per kg. Another is at 70 rupees per kg. He buys 40 kgs of the first variety, very similar to the previous question now, but over here, what they've done, they've given you this quantity. And how much should he buy of the second variety? So I'm taking X kgs for the second variety. If he wants the mixture to be at 65 rupees per kg. If you are able to organize this data like this, you are getting down to the answer very, very quickly. Because let me quickly show it to you as to how will I do it very, very quickly. And then of course, I'll make the generic equation and show it to you. So I'm going to say that, look, A will create a deficit as it is less than my average. So it will be a deficit of 25 rupees per kg. And I've taken 40 kgs of this. So multiplied by 40 must be equals to what? 70 will create a surplus because it is more than my average. It will create a surplus of 5 rupees on every kg. And how many such kgs I've taken? I've taken X kgs of this. So this is 5 and this is going to be 200 kgs of the second variety must be taken in order to get this mixture at 65 rupees per kg. Now, if you want to make your equation, of course, I will just expand what I've written over here and write it once again. It is going to be 65 minus 40 as my surplus on 1 kg. How many kgs are there? 40. So this is going to be my total deficit. I'm sorry, I called it surplus. It will be a total deficit. 65 minus 40 into 40 should be equals to surplus of 70 minus 65 on 1 kg multiplied by the number of kgs. Again, you will get to the same answer, of course, which is 200 kgs, right? Let's move on and let's now look at question number 3 and onwards. Of course, now the drill becomes similar to what we have done in the previous videos, wherein I'll give you a certain amount of time to do the question and then we will move on, okay, and try and solve those questions. So start with question number 3 and take a minute and a half's time. Last 20 seconds. Let's have a look at this question. Now, what is this question talking about? This is saying 50 liters of a solution of milk and water in the ratio 1:4. Now, remember, this is ratio as 1:4. Ratio is not average. When you look at strength, that's the average concentration. That if you take any one part out of this, what will happen is this will be the average concentration that you will get for a particular variety of ingredient. Now, 50 liters of a solution of milk and water in the ratio 1:4 is mixed with another solution. So there is a solution A, there is a solution B. 50 liters of the solution A has been mixed with another solution of milk and water in the ratio 4:1. So now what is the strength of milk and water over here? It is 1:4 as the ratio. So strength of milk will be what? 1/5. This is the average quantity of milk that you will have on any part that you take. So if you take 50 liters, you will find 1/5 of 50. If you take one liter, you will find 1/5 of 1 will be the quantity of milk in that particular portion. So average quantity of milk in the solution A was 1/5. With another milk and water solution, which is 4:1. So there is another milk and water solution, which is 4:1. Now remember, I've used the strength of milk over here. So I will have to use the strength of milk over here, which is 4/5. To get a solution containing milk and water in the ratio of 7:3. After mixing these two, we are getting a solution in the ratio 7:3. That means what is the strength of milk? Once again, I'll not be using ratio, I'll be using strength. So this will be 7/10. How much was the quantity of milk in the second solution? How much was the quantity of milk in the second solution? They're not talking about the quantity of second solution, mind you. They're talking about the quantity of milk in the second solution. So first I will try to find out the quantity of second solution and then take 4/5 of that value, right? Let's look at this. 1/5 as the strength, 4/5 as the strength, 7/10 as the strength. If you look at 7/10, it's 70%. If you look at 4/5, it is 80%. If you look at 1/5, that's 20%. So what are we then effectively saying? That B is a variety which has got relatively more amount of milk as compared to the final mixture, right? So this will create a surplus. This will create a deficit. Now surplus of how much? Surplus of 4/5 minus of 7/10 on one part of B. That will be the surplus. How many parts of B I've taken? I've taken X parts of B. I've taken X liters over here, but if it would have been in milliliters over here, I would have taken milliliters over here. So that is why I'm saying that if I've taken 50 parts of A, then I'll take X parts of B, right? So this will be the total surplus that it will create. What will be the total deficit that it will create? It will create a deficit of 7/10 minus 1/5 into 50. Why into 50? Because that's on 50 liters that we are talking about. This part will be a deficit on 1 liter, if we wish to call it. Multiplied by 50, that will be 50 liters, right? Let's just solve this. So this will become 8 minus 7. So 1/10x. The value should be over here 5/10 into 50. This will get cancelled out. The value of X will be what? 250 liters. Right? So I should have taken 250 liters of the second solution, but remember, they are not asking you the quantity of second solution. They are asking you the quantity of milk in the second solution. Quantity of milk in the second solution should be 4/5 of 250. And that should be what? That should be 200 liters. So how much quantity of milk was there in the second solution? It was 200 liters of milk in the second solution. Of course, the total solution was now 250. So I will call 50 liters as water in that. Right? So let's move on. Let's look at the third question. Try and again organize the data the way I have asked you to do. Take a minute's time and try and solve this. Questions based on averages. Last 20. Right. So let's move on and let's look at question number 4. It says what? A group of 5 students has an average of 62. Now, I'm not going to go by the conventional approach of adding all the numbers and dividing it by 5. All of that is something that I believe if you are planning to appear for any competitive exams, you will be able to do it if you have certain basic knowledge, right? Let us try and have a better understanding of the topic, and let's see how can we do a lot of calculations in our mind, understand the data better. So let's have a look at this. A group of 5 students has an average of 62 kgs. One of these students need to be replaced so that the average decreases by 4 kgs. We need to replace one of these students and the average should come down by 4 kgs. What should be the weight of the new student if the expelled student's weight is 70 kg? Okay, so you have a student who has been removed out of these 5 and is replaced by another student. You need to figure out what is the weight of this new student who is coming. Okay, average group of 5 students has an average of 62. So let me say that these are the 5 students A, B, C, D, and E. And the average weight is 62. So let me give 62 to each one of them. Let me give 62 to each one of them. One of these students need to be replaced so that the average weight decreases by 4 kgs. Average weight has to what? Average weight has to decrease by 4 kgs. That means the new average that you are looking at must come down to 58 for each of the students. One of these students is of course replaced. So I will have to choose out of A, B, C, D, E, one student to be replaced. Let's say suppose it was E which was being replaced. And what was the actual weight of E? It was 70. Now please understand, if this weight is 70 and I am looking at equal distribution, of course, the average is 62. That means E would have naturally created a surplus of 8 units, right? So what E will do? E will bring him back to 62 and this 8 E will distribute to each one of them, right? If 8 has to be equally distributed between 4 of them, each one of them would have got 2 kgs from E. That means if I forget E, the average of A, B, C, and D must be 60 because they were getting 2 kgs from E, right? So their own average should be 60. Now what are they saying? They are saying that this 70 kg is replaced by another student and average of everyone has come down by 4 units. So from 62, it has come down to 58. So what will happen? From the 60, they are now coming down by 2 units each. Where is this 2 units going? This 2 units, of course, all of these are coming down by 2 units. That means these 2 units are going to the third person, the person who is now coming in. And then that person is reaching a weight of 58 kgs. That means this particular person is getting 8 kgs from all of them put together. So this person should be at 50 kgs plus an 8 would then give me 58. So this new person who has been replaced, who is replacing E is of 50 kgs, is bringing in 50 kgs as the weight, right? Then only this will happen, that the average will come down from 62 to 58 when you replace a person from 70 kgs by a 58 kgs of weight, right? So this is something that we need to understand, and we can do the questions like this. Also, we need to understand that you can do a lot of these calculations a lot faster in your mind if you're able to understand the concept of equal distribution very clearly. So focus there as the concept of equal distribution. Let's move on. Let's look at the next question. Again, a question based on averages, and I'm going to give you a minute and a half's time to try and solve this. Thirty more seconds. Right. Let's have a look at question number 5. It's a very interesting question to my mind, and you can apply your concept of surplus and deficit and can get down to the answer very, very easily. But there's just one condition that you've got to be very clear in your mind as to what that concept is all about. Spend about 1 hour of time with that particular concept, trying to understand, look at the first few questions very critically, try and analyze why are we doing what we are doing. And then I think you will be able to apply it on any of these questions. So let's have a look at this. A CAT aspirant appears for a certain number of tests. His average score increases by 1 if the first 10 tests are not considered. Okay, so let me take the number of tests over here. Let me take the number of tests that he has appeared for as A, and his average is increasing or decreasing. So let me take the average of these tests B. Let's say a value B. Right now, what is the question saying? His average score increases by 1 if the first 10 tests are not considered. Okay, his average of the total test is B, and his average is increasing by 1 if I'm not considering the first 10 tests. Now let us understand this thing. You take a total number of tests as A, so A minus 10 tests is what you are talking about, and over here I'm taking the 10 tests, first 10 test, first 10 I'm talking about over here. So what will happen if I take all of these tests together, A minus 10 and 10? So I'm looking at all the tests. What will be the average marks? B. But if I only consider these A minus 10 tests, then I am increasing the average by 1. That means my average of the test will be B plus 1 for these A minus 10 tests, right? As of now, I don't know what is the average of the first 10 tests. And it decreases by 1 if the last 10 tests are not considered. Okay, so again, if I don't consider the last 10 tests, the number of tests will be A minus 10. But remember, over here, these are different set of tests. Okay, these are not the same set of tests, but the number of tests is same over here. A minus 10 will be same in both the cases, right? If I don't consider my last 10 tests, so these are also 10 tests, but of course they are different from these 10 tests. These are last 10 tests. The average decreases by 1. That means over here, the average value should be B minus 1. If I don't consider the first 10 tests, the average last 10 tests, it is decreasing by 1 mark. So this should be B minus 1. This should be B, right? If his average score for the first 10 and the last 10 tests are 20 and 30 respectively. So for the first 10 tests, the average marks is 20. For the last 10 tests, the average marks is 30 respectively. Then the total number of tests taken by him is what? So you are looking at the number of tests as A. Now, these are two different mixtures that we may call it. Okay. So over here, we are combining these two sets of tests. Over here, we are combining the other set of tests, right? So let us now understand. Of course, your value of B plus 1 is greater than B. So of course, this type of test will create a surplus. Surplus of how much? B plus 1 minus B. This will be the surplus on one test. How many such tests are there? A minus 10 tests are there. A minus 10 tests are there. Same way over here, what will happen? Of course, if B plus 1 is more than B, then of course 20 must be less than B. 20 must be less than B. So 20, this set of tests will create a deficit of how much? B minus 20 on one test. And how many such tests are there? 10. Let's have a look at this equation. B and B will get cancelled out. So 1 into A minus 10 will be A minus 10. And this will be 10B minus of 200. So if you go further, what will you get? You will get 10B minus of A will be equals to 190. This is the first equation that we are doing. Let's look at the second equation similarly over here. Of course, now B minus 1 is less than B. That means B minus 1 will create a deficit and 30 will create a surplus. If B minus 1 has to create a deficit, then I'm going to say B minus of B minus 1. That will be the deficit on one test. How many such tests are there? A minus 10 tests are there. This value must be equals to 30 minus B. That will be the surplus on one test out of these last 10 tests, and multiply this by the number of tests to get the total surplus, which is 10. Let's just solve this. B minus of B plus of 1, right? So B will get cancelled out over here. You will get plus 1. So you will get A minus 10 to be equals to 300 minus of 10B. So what we will get over here is 10B plus of A to be equals to 310. If you look at these two equations, you can of course get down to the values of A and B very, very easily. So if you add the two equations, you will get 20B is equals to 20B is equals to 500. That means the value of B will be 25. And same way, if I take the value of B as 25 and put it back over here, I'm going to get the value of A as 60, right? So what was the question asking you? The number of tests taken by him, number of tests taken by him is A, which is 60, right? That will be the answer. Now, again, a beautiful question that you can do if you know the concepts really well, if you apply yourself, look at the word average in any of these questions. And I would want you to think for once, can we organize the data like this? And if we can, then we are through with this question. Let's move on and let's look at the next question, question number 6. Again, a minute's time, not a very difficult one. Twenty seconds. Again, it's an interesting question. And why am I calling it as an interesting question is because quite a lot of us will look at this question and try to apply profit and loss. Of course, you will get down to the answer if you apply that knowledge as well of profit, loss, and discount. But the point is that you could do this question very, very easily with the help of the allegations approach that we have just spoken about, the surplus and deficit approach that we have just spoken about. A merchant sells 1/4 of his goods at a profit of 20%. You are selling 1/4 of the goods at a profit of 20%. So I'm taking 1/4 of the goods and the average profit on the cost of these goods is 20%. I'm taking it as plus 20 because it is profit. When it will be loss, I will be taking a minus, right? So for the rest of the goods, he's generating a loss of 10%. So I'm taking a minus 10. What is his profit or loss percentage overall? Now, please understand the overall profit or loss percentage has to be between a profit of 20% or a loss of 10%, somewhere in between that, right? So let me take that percentage as X percentage. Now we need to understand that this 20% must create a surplus and this 10% loss must create a deficit. Of course, 20 will be greater than X, right? So let me take that equation and say 20 minus X will be the profit on one part of these goods, right? I've taken 1/4 of these parts. So I'm going to say 1/4. This will create a surplus. So this is the surplus part of the equation. What will be the deficit part of this equation? X will be greater and minus 10/5 will be lower. So I am going to say X minus of minus 10. This will be on one part. There are total of 3/4 parts of this, right? Please understand, if you would have taken Y as the total quantity, taken 1/4 of this, you would have got 1/4 of Y and 3/4 of Y, and Y would have got cancelled out. So that is why I'm directly dealing with 1/4 and 3/4. I'm not taking a certain quantity because that will eventually get cancelled out. So this 4 will get cancelled out. What we'll get 20 minus of X should be equals to 3X over here. And then I'm going to get plus 30. So what will I get? I will get 4X as minus 10. And what will be the value of X? Minus 2.5. Now we need to understand over here that there's no problem if I'm getting a negative value. I had used a negative sign for a loss, right? So of course, then this is a loss. And what are we getting? Loss is 2.5%. Loss of 2.5%. That will be the answer for question number 6. A question that you could have done with the help of surplus and deficit very, very easily. In fact, if you look at it, once you make these equations probably 10 odd times from 11th or for some of you from 25th time or 50th time, you will realize a lot of these calculations you can do on your mind and you will not struggle with this. Okay, let's move on. Let's look at the 7th question. Again, one minute of time, try and solve this question. Last 15. Let's just try and solve this. The ratio of copper and iron in two alloys are 2:3 and 3:7. Remember, they are talking about two alloys. So I'm going to take alloy A and I'm going to take alloy B. The ratio is 2:3 and 3:7. So can I say what will be the strength over here? The strength over here for copper will be 2/5. And what will be the strength of copper in the second alloy? That is going to be 3/10. These were melted to get a new alloy with copper and iron. Copper to iron ratio is 19:31. So what will be the strength over here? 19/50. What was the quantity of the first alloy if the total quantity of the mixture was 100 kgs? Now, please understand, we know that we can actually figure out the ratio and then can get down to 100. Or you can take one of the quantity as A and then take the other quantity as 100 minus A and then try to do the question, right? Now, I'm going to take A kgs of this and I'm going to take B kgs of this, find out the ratio, and at the end, I will divide the total 100 kgs in that ratio. Okay. Now, when you look at such figures, you can, of course, apply your mind and try to get down to a better figures, which will help you solve your equations a lot quicker. 3/10 as a ratio, you have got a 50 in the denominator. Of course, you cannot change this 50 in this ratio. Why? Because there's nothing in the numerator that is getting cancelled. So if at this level, I have a denominator 50, I can solve it easily. So instead of writing 3/10 over here, I'm going to write it as 15/50. And same way over here, instead of writing 2/5 over here, I'm going to write it as 20/50 by multiplying a 10 in the numerator and denominator to get a 50 in the denominator. Now, what am I going to say? Of course, 20/50 will be greater and 15/50 will be lesser as compared to 19/50, right? So A should create a surplus, B should create a deficit. So 20/50 minus 19/50 into the quantity A must be equals to what? Must be equals to 19/50 minus of 15/50 into the quantity B, of course. Now let's just solve this. This is 50. I'm so sorry for my writing. This is going to be 1/50 into A. That should be equals to 4/50 into B, and the equation become, we are able to solve this very, very quickly. A by B is 4/1. Now, what is that they're asking you? What was the quantity of first alloy if the total quantity was 100? The first alloy was 4 parts out of a total of 5 parts. So 4/5 of 100, that's going to be 80 kgs. So 80 kgs will be the answer for this question, right? Once again, I'm doing exactly the same thing, surplus, deficit. Look at it as a bunch of things for the first variety, second variety, and try and get down to the average. Let's move on and let's look at question number 8. Again, a minute's time for you to solve this. Last 20. Right. Let's have a look at question number 8. It says a mixture contains alcohol and water in the ratio of 4:3. Okay. 8 liters of water is added to this. So you are then saying that there is a mixture which has got alcohol and water in the ratio of 4:3. So what is the alcohol strength? 4/7. And 8 liters of water is added. 8 liters of water will have what strength of alcohol in it? 0 parts of alcohol, right? If 0 parts of alcohol, 0 will be the strength of alcohol in pure water, right? So 8 liters of water is added to the mixture. The ratio of alcohol and water becomes 3:5. So this should be 3/8 as the alcohol strength. Find the quantity of alcohol in the mixture. You have to find out the total quantity of alcohol in the mixture, in the final mixture that you are getting, right? So now 4/7 will be greater, 0 will be lesser. So 4/7 will create a surplus. We will say 4/7 minus 3/8 multiplied by x should be equals to 3/8 minus 0 into 8. Let's just try and solve this. 8 sevens are 56. So 8 fours are 32. 32 minus 21, which is going to be 11/56 into x should be equals to 3/8 into 8 would then turn out to be equals to 3. So we will get x is equals to 3 into 56 divided by 11. That will be the value of x. Now, what is the question asking you? Find the quantity of alcohol in the mixture. Now, understand this thing. In this final mixture, the alcohol is coming only from this part. So whatever is the quantity of alcohol over here will be a quantity of alcohol over here as well, right? So what am I going to do? I'm going to say 4/7 of x will be alcohol, right? And what is the value of x over here? 4/7 into 3 into 56 divided by 11. 7 8s are 56 and 8 3s are 24. 24 into 4 is 96/11. That will be the quantity of alcohol, 96/11 liters as the answer for this question, right? Please do not try to solve these equations over here. If there is something which is not getting cancelled, it's okay, let it be there. At the end, you will find things get cancelled out or not. If not, then we will at the end solve this equation. There's not much of a problem, right? If required. Let's move on. Let's look at question number 9. Again, a beautiful question. Take a minute's time. I'm giving you a 30 seconds more. Keep trying. Let's have a look at question number 9th. Let's try and solve this. Another very interesting question which has got a very clear application of your mixtures and solution type of questions or allegations types. Okay. A chemist mixes the two liquids A and B. 1 liter of liquid A weighs 1000 kilograms. Now, understand this thing. I can say they're trying to give you the average. That means 1 liter of liquid will have how many kilograms? That's the average quantity that they're giving you, that 1 liter will have this much weight, and 1 liter of the liquid B weighs 800 grams. So that's the average that they're giving you, 1000 grams per liter over here. So I'm going to write the liquid A and say it is 1000 grams per liter as my average. And what is the average for the quantity B, for the liquid B? It is 800 grams per liter. 800 grams per liter. If half liter of the mixture weighs 480. Now, please do not write 480 because you are taking grams per liter over here, grams per liter over here. You will have to take grams per liter over here. And they've given you only for half a liter. That means for 1 liter, what will be the weight? For 1 liter, the weight will be 960 grams. Please do not take 480 over here, right? This has to be 960 grams per liter. Of course, this 480 should definitely not make sense because if you keep 480 over here, then that is lower than this value also, and that is lower than this value also. That is not possible, right? Then the percentage of liquid A in the mixture in terms of the volume, right? Let me take A liters of this variety. Let me take B liters of this variety to create this mixture of 960 liters. I just need the percentage value. So I don't have to get down to the individual absolute quantities of A and B, right? So what will I say? 1000 grams per liter minus 960. that will be a surplus on one part or 1 liter, right? How many such liters have I taken? I've taken A liters. Should be equals to 960 minus 800 into B. So what we will get over here, 40 into A should be equals to 160 into B. So A by B should be equals to what? 160 by 4, 160 by 40 or 4 by 1, right? This should be 4 by 1. Then the percentage of liquid A in the mixture will be what? 4 by 5 into 100. That's going to be 80%, right? Again, a question which we might try to do it by making equations, by doing, by applying arithmetics logic to this. But I would then suggest that if we can think in terms of averages, this will help us solve it very, very quickly. This is, to my mind, one of the questions coming from your CAT paper. Very recent CAT papers is what we are looking at. Let's try one last question for the day. Question number 10. Again, a minute's time for you to solve this. Twenty seconds more. Right, let's try and do this. Two liquids are mixed in the ratio of 5:7. So you have taken liquid A and liquid B, and they are mixed in the ratio of 5:7. So you are taking 5 parts of liquid A and 7 parts of liquid B, and the mixture is sold at 200 rupees per liter with a profit of 25%. Understand this thing, that what is the relationship between selling price and cost price? If it is a profit of 25%, selling price should be 25% more than the cost price. So 5 by 4 times of the cost price, and that selling price they have given you 200 rupees per liter. So this should be 5 by 4 times of the cost price. So what will be the cost price of the mixture? The cost price of the mixture should be 160 rupees per liter, right? Now, if the first liquid is costlier than the second liquid by 144 rupees per liter. So if I'm taking X rupees per liter for the variety B, for the variety A, it should be X plus 144 rupees per liter. Right? Find the cost of the two liquids. Understand this thing, that only the relationship between cost was given to me over here. I could not have used my selling price over here. I will have to use my cost price only over here, right? Which is 160 rupees per liter. Now, of course, X plus 144 is greater than X, and 160 has to lie somewhere in between this, right? So what am I going to do? I'm going to say X plus 144 will create a surplus. So we will make an equation which says X plus 144 minus of 160 into the quantity A, which is 5. So 5 parts of this and 7 parts of this, right? This should be what? 160 minus of X into 7. We will just try to solve this equation. This will be X minus of 16 into 5 should be equals to 160, 42. So 1120 minus of 7X. So let's go further. We will look at 8X over here. And 1120, 16 5s are 80. So we will look at 1200. And this should be, just a second, this should be 7X and 5X. So this should be 12X over here. So what should be the value of X? The value of X should be 100. Now, what are they asking you? Find the cost of the two liquids. The cost of two liquids will be 244 rupees per liter for the variety A for the first liquid. And of course, then 100 rupees per liter for the second variety, right? So that will be the answer to this question. We will be having one more part of this series, which is mixtures and solution as a larger topic. We will be doing removal and replacement in the next video, right? So that's about it for this video, guys. Thank you so much. Please do like the video and subscribe to the channel. If you are not a part of our 100 Days to CAT program, please find the link of registration in the description of this video. Fill it up. We will add you to our Telegram group. And there are a lot of things in store for you on that, right? So that's about it for this video. Thank you.